Alright, this is lesson 33 for 7th grade, and today's topic is comparing and rounding decimal numbers. So I didn't write down our goals today, but basically what we want to be able to do is when we look at comparing decimal numbers, we're going to want to determine whether or not, if let's say we have two decimal numbers, are they the same, are they different, if they are different, which one's bigger, which one's smaller, that type of thing. So we're looking at place value and some things like that, and we're also going to use place value to help us round our decimal numbers, and we're going to find out that rounding with decimals is no different than rounding with whole numbers. So first we'll look at this little paragraph. When comparing decimal numbers, it is necessary to consider place value. The value of a place is determined by its position with respect to the decimal point. Aligning decimal points can help to compare decimal numbers digit by digit. So we'll do it that way. So if we look right here at this first one, we have 3 decimal numbers, and we want to order those from least to greatest. One thing that the book suggests that we do is aligning those decimal points, so we have digit by digit. So if we go 0.13, 0.128, 0.0475. Now, we don't have as many digits with this one as we do here or as we do here. But what we can do is add zeros here. That won't change our numbers. We can do that if it's after the decimal point. And that won't change what these numbers are. It's just a better way to compare. But what we want to do is look at our first column here, 1, 1, and 0. That tells me that this is our smallest number that we have, because the closer we are to the decimal point, the larger numbers we're dealing with. So this would be tenths, this would be hundredths, thousands, 10,000s. So these numbers here, they both have a 1 in this column. We're looking for the biggest number in this column, basically. 0 is definitely smaller than 1, so our smallest number is going to be this one. So I'm going to go ahead and give that a 1 there. These two are the same, so we have to go to the next column, and we're looking for the bigger number. So we're looking at 3 and 2, and 3 is bigger than 2, so this is going to be our second biggest, and this should be our third biggest. So if we order those, it should be 0.0475, 0.128, 0.13. So even though 0.13 had the least amount of digits, it's still the bigger number when we look at it via place value. If we were to turn these into percents, this would be 13%, this would be 12.8%, this would be 4.75%, just moving our decimal spot over. So that's another way we could have looked at it. Alright, so let's compare these two. Now if we just look at it the way that I just said and talk about percents, that's just moving your decimal spot over 2 spots to the right. So this would be 12%. This would be 1.2%. This is what I like to do to compare. You don't have to do it this way, but we can clearly see that the alligator is going to eat that 0.12 because it's the bigger number. If we wanted to do it the way that the book said, we could align our decimal point. Okay? And 1 is bigger than 0, so this is going to be the bigger number. That's another way we could do that one. Here's another one here. Now if we align these decimal points, which one's going to be bigger here? Well, we have 4 and 4. Okay, so those are the same. Then we have nothing over here, but remember I said we could add zeros afterwards, and it won't change what we have. So these are actually the same. They are equal. If I were to turn those into percents, we would get 40% for both of these. So this is 40%, this is 40%. Or the way to read it, decimalized 4/10 is what we have there. And they are equal. And I believe we have one more for the comparing here. There we go. Compare 1.232, 1.23185. Okay, so let's line those up. 1.232, 1.23185. Alright, so we can see that they're both 1. We have 1 in the ones column. In the tenths column we have 2's. In the hundredths column we have 3's. So they're the same up until the hundredths. And then when we get to the thousandths, that's when we're different. Okay? We're going to compare the 2 and the 1 there. Well, the 2 is bigger, so we're going to say that this number is larger. So 1.232 is bigger than 1.23185. They are close, but this one is bigger. Alright, so that's how we compare decimal numbers. Now let's take a look at some rounding. It says to round decimal numbers, we can use the same procedure that we use to round whole numbers. And we'll use that on this. This is an approximation of our number pi that we use to help us find the circumference and area of circles. We usually use 3.14, but it says to round to the nearest hundred. So, this is your tenths, this is your hundredths. So we're going to round that number by looking at the one to the right of it. Now if the one to the right is bigger, or 5 or bigger, then we're going to round this up. If it's 4 or less, we're going to keep this the same. And this is less than 5, so this will be 3.14. So that's why we use 3.14 for pi when we do those calculations sometimes, because we just round it off to the nearest hundred. Alright, let's take a look at this one. Round 4,396.4315 to the nearest hundred. Alright, big difference between these two. This has the TH, that was hundredths. This one's just hundred. So we're looking at on this side of the decimal. So we're going to round the hundreds by looking at the tens spot. Alright, 9 is 5 or bigger, so we're going to round this up. And we should get 4,400 for a rounded answer there. 4,400. So we got to be careful as to which place value they're talking about there. Okay, moving on. I think we have 2 more examples here. Round 38.62 to the nearest whole number. Okay. So the nearest whole number would be on this side of the decimal here. And we're going to look at our ones place. We're rounding that by looking at that. Okay? So remember, whole numbers means no decimal. So no decimal. 6 is 5 or bigger, so we're going to round that up to 39. Okay? And lastly, estimate the product of 12.21 and 4.9 by rounding each number to the nearest whole number before multiplying. Okay? Well, we're going to round to the nearest whole number again. So we're going to look here, and here, and here, and here. 2 is less, 4 or less, so we're going to keep this at 12. And 9 is 5 or bigger, so we're going to round this up to 5. So now we have 12 times 5. So to estimate the product is multiply. 5 times 12 should give us 60. So that would be the estimated version of that. Alright. Those are all the examples I have for today. We'll be going over this tomorrow, and we'll see you then.